According to the literature, it is possible to define the torque as a relation between the power consumption and rotational speed, as is shown in the following expression. Due to power values for Reynolds number between 1 to 1000 are nearly zero, it is expected that torque for the same Reynolds number range has values of zero as well, which is consistent with the results obtained in the simulation. In addition, simulation results indicate that as the velocity of the impeller increases, the force applied to the fluid is greater.
This graph illustrates the values of the shear rate stress versus shear rate obtained from the simulation using the Rushton impeller and the Smith impeller. It is noticeable that the shear rate is directly proportional to the shear stress. Due to the fluid used in the simulation is water, which is a Newtonian fluid, and comparing with the literature, the behavior represented in the graphs with the simulation values is the correct one. For both impellers, we see the same behavior. As the number of Reynolds increases, the shear rate increases. However, the Rushton impeller is a little bit higher. This is due to the geometry it has, because having straight blades increases the shear stress. The power number is a dimensionless number that gives an idea of the total amount of power required for the operation of the agitator. So, it is expected that as the viscosity of the fluid increases, the power number raises as well, because more energy is required to move the flow. If the fluid was non-Newtonian or more viscous, the impeller used would not be accurate. This is because for mixing a non-Newtonian fluid, if the shear rate was as big as the one worked in this case, the fluid would not behave as a liquid but as a solid. This happens because of the non-linear behavior of the viscosity, which can be modified by temperature or shear rate. Also, the regime reached would not be a turbulent one but a laminar, this to keep a constant behavior in the fluid's viscosity. For agitated tanks, the effect of the gravity force on the power number is negligible, so the power number is generally considered a function of the Reynolds number. As mentioned before, theoretically applying the Navier-Stokes equation for turbulent motion in an agitated tank is difficult and practically impossible because the variables in the equation refer to instantaneous values at a local point. The power number is constant when the turbulence is very developed and the Reynolds number is larger than 10,000. This means that the total energy consumption in a stir tank is independent of the viscosity and is a function of only the geometric design of the impeller and its speed. This is an indication that the energy of the large eddies created by the impellers is independent of viscosity. The flow pattern is more erratic with baffles than without. For an unbaffled tank, tangential velocities produced by turbine impellers are high relative to radial and axial components.